Hey everybody! So welcome back. Today we're going to be talking a little bit about the appendicular skeleton. The appendicular skeleton is the appendages. Last time we talked about the axial skeleton, which is the central axis of the body. So the skull, the vertebrae, the thoracic cavity. Now we're going to be talking about the appendages, which is basically the arms and the legs. Um, and also the girdles that hold those arms and legs to the axial skeleton. So in your appendicular skeleton, you've got 126 total bones. We're going to have to go through them all. And that includes both arms, both legs, and again, the shoulder and the hips that attach everything together. All right, so we're going to start off by talking about the shoulder girdle, also called the pectoral girdle, so up here in your shoulder. The shoulder joint itself is going to consist of the scapula, the clavicle, and the humerus. So I'm going to bring over this guy here so he can show us a little bit about what this looks like. So if we're looking at the shoulder, we have a clavicle up here, that's your collarbone. In the back here, we've got the scapula. Oops, get in the frame here. This is your shoulder blade, right? So your shoulder has a couple different parts to it. We'll talk about the details of those in a second. But then clavicle, scapula come together here, and then we've got the bone of the arm, the humerus, that's part of that. So we can see all three of those bones together form the shoulder girdle. All right, so a little bit of a closer look at the shoulder girdle. So here in this slide, you can see an anterior view, so a view from the front of the body, and also a posterior view. So we can see that the shoulder girdle is more visible, I think, from the posterior view over here. So we can see the full view of the scapula, how the humerus here locks into the scapula, and then the clavicle comes around front. So these two bones actually make kind of a triangle here. So clavicle, scapula working together to basically hold this part of your body together, hold the arm to the rest of the body. All right, so focusing in on just the clavicle itself. So clavicle is this little S-shaped bone, this collarbone, right? So you can feel your collarbones right here. It's got two ends to it. The sternal end, which is the end that attaches to the sternum. So we can remember the sternum is right here, right here. So the clavicle is going to have a sternal end that attaches right to the sternum itself. And then we've also got an acromial end. The acromial end is called that because it attaches to the scapula at a point called the acromion process. So this kind of pointy part of your shoulder, if you can kind of feel right there, that's the acromion process of your scapula. That's where the acromial end of the clavicle fits in. Okay, so looking at the scapula itself, so I'll turn this guy around a little bit so we can see his scapula. So looking at the scapula, there are a few different pieces and parts to this bone that we should understand. So the spine is this large part here. So the spine is this kind of projection of the bone. You can feel along your back. That's this large process that kind of points outward towards the shoulder. So on both sides of the body, it's going to be pointing outward towards the shoulder. That's the spine of the scapula. We've also got the acromion, which I mentioned just a second ago. So the acromion is this point on the tip of the scapula. So this lateral most portion of the scapula is the acromion process. We've also got the coracoid process. If I flip this guy around a little bit and we look at the front here, we can see the coracoid process from the front of the bone. Right, so this coracoid process sort of sticks out here. He doesn't articulate with any other bones. He's just kind of floating out there. He's there for attachment of muscles and ligaments that are involved in the shoulder joint. In addition to those processes, we also have a cavity here, and that's the glenoid cavity, sometimes called the glenoid fossa. So that glenoid cavity is this kind of indentation here on the bone. Let me grab an unarticulated one so you can see. So here's a scapula. If I point it this way, you can kind of see this depression here. That glenoid cavity is there to fit the head of the humerus. So that's where the arm bone fits into this bone. All right, so there's another view of your shoulder or of your scapula there. So we can see all those major parts to it. So the spine of the scapula, the acromion, which is the lateral tip of that spine, the coracoid process, which is kind of an anterior projection, and then the glenoid cavity or glenoid fossa, which is where the head of the humerus is going to articulate with this bone. Okay, so moving down to the arm. So we've got the major bones of the shoulder here, but we're going to move down into the arm here. Your arm has one bone, and that one bone is the humerus. So the humerus is the bone of your arm. It's got a few projections and little interesting parts of it that we should talk about. So we've got greater and lesser tubercles. The tubercles are these projections of the bone up here. So I can kind of, I don't know if you can see super well in my video here, but greater tubercle, lesser tubercle. These guys are, they're basically projections of bone that in between those two projections of bone is where the tendon for your biceps femoris or your biceps brachii muscle runs through. So right in between those two little tubercles or bumps on the bone is where part of your biceps runs through. All right, so those are the kind of main parts of the humerus up here. So head and then greater and lesser tubercles. As we move down, so the rest of this guy's arm, all right, so we get into the forearm, right? So the arm is just the humerus up here. Down here we get into the forearm. So forearm has two bones to it. Those are going to be the radius and the ulna, right? So radius is always going to be on the thumb side of your forearm. Ulna is always going to be on the pinky side of your forearm. So when we're in anatomical position, which we remember what anatomical position looks like, the radius is always lateral and the ulna is always medial or closer to the midline of the body. Right, so those are your two bones of the forearm. These bones fit together here to form your elbow joint. So I'm bending this guy's elbow here. And we can see that the ulna, which is this bone here, this one long one here, has this kind of hooked end to it. That hooked end is called the olecranon process. The olecranon process of the ulna fits into the humerus, and that's what allows for this hinge-like motion of your elbow. So olecranon process of the ulna fits into the humerus to form a hinge joint, and that's your elbow joint. Okay, so let's look at these two bones again, the two bones of your forearm. So ulna here, radius here. These two bones are held together by a sheet of connective tissue called an interosseous membrane. So that means that there's a sheet of tissue holding these two guys together so that they don't move too far apart from one another, right? So there are joints between these two bones. If you think about it and you just kind of are looking at your forearm, you have the ability to rotate your forearm. So we can move these two bones around one another, but not too far apart from one another. And that's because they're being held together by that interosseous membrane. All right, so this is a zoomed in look at that elbow joint. So we can see here, let me grab my highlighter here. So we can see here that olecranon process of the ulna. So down here where the ulna's kind of got this U shape and it's going to grab into the humerus here. So this is your humerus coming down this way. So that olecranon process is what is allowing for that hinge joint action to happen. Also, I'm going to look at the radius real quick here. So the radius has a radial head to it. And so this is a rounded head. Let me grab a disarticulated one. So if I look at, this is just a radius on its own. So this is what your radius looks like. If I orient it this way, let me get it into the camera here, we can see that the end of this bone is really round. So when you think of radius, think of like the circles are really round. So that rounded end to this radius is what allows for that kind of twisting motion of your forearm because that rounded head can just kind of roll across that joint and allow for a rotational movement. All right, and there's a zoomed in view of the ulna. So again, ulna has that olecranon process, which is kind of that curved shaped process on the end of it. It almost looks like a U, so think of U for ulna. So when you see that kind of curved olecranon process, you're definitely looking at an ulna. All right, moving down into the hand. So the hand gets a little complicated. So now we're going to add a whole bunch of bones here because we've got your carpals. Carpals are the bones of the wrist. And then we've got metacarpals, those are the bones of the hand. And then we've got phalanges, and those are the bones of the fingers. So we're going to go through all of these different bones and talk about what they're called and what they're good for. Okay, so looking at the hand itself, so you have 5 fingers. So you basically have 4 fingers and a thumb. So these are your phalanges. They are mostly composed of 3 bones. So each of your 4 fingers is composed of a proximal phalanx, a middle phalanx, and a distal phalanx. And that's true for each one of them. So proximal, middle, and distal phalanx. Those are the names of those bones. So if I grab this guy's hand here, and we can see proximal, middle, and distal phalanx. Proximal, middle, and distal phalanx for each of these 4 fingers. Your thumb, or pollex, just has 2 phalanges, so a proximal phalanx and a distal phalanx for the thumb. Okay, so those are just the fingers. The hand itself, so like the palm of your hand, is composed of metacarpals. So, and you have 5 metacarpals, they're just numbered. So metacarpal number 1 is on the thumb side, metacarpal number 5 is on the pinky side. Right, so metacarpal 1, second metacarpal, third, fourth, and fifth metacarpal there. And the same thing is true for how we number the digits. So your thumb is the first digit, your pointer finger is the next digit, middle finger is the third, the ring finger is the 4th digit, and your pinky is the 5th digit. All right, so that's the hand and the fingers. Now let's look at the wrist. Right, so the wrist down here has a whole bunch of little bones to it. So there's actually 8 bones in your wrist. Those are called your carpals. The carpals each have their own name, which you will have to learn. So the 8 carpals, there are a few different mnemonic devices you can use to memorize these. I'm going to point at this guy's hand and kind of walk you through them here. So we always start, or at least I do to help me remember, always start at the thumb side and go from proximal to distal, starting from thumb to pinky. So they're basically arranged in 2 different rows. So this first row is 4 bones, this next row is 4 bones. So the first one down here is your scaphoid. Right, so the scaphoid is this first one on the thumb side. Next to that is the lunate, so scaphoid, lunate. Next to that one, this little guy up in here is called the triquetrum, so triquetrum up in there. And this one here is called the pisiform, so scaphoid, lunate, triquetrum, pisiform. So that's the first 4 bones on the wrist. Then we move up a little bit distal to this next row of bones, which is closer to the palm of the hand. Those ones are the trapezium, trapezoid, which you can kind of see this little one in here, capitate, and hamate. So trapezium, trapezoid, capitate, hamate. Okay, so those are the 8 bones of your wrist. So scaphoid, lunate, triquetrum, pisiform, trapezium, trapezoid, capitate, hamate. Right, so those are the bones of your wrist. All right, here's a little mnemonic device that's from your learning maps that might help you remember these in order. So just to remember the first letter of each of the names of the bones, you're still gonna have to memorize the names of the bones, but at least it'll help you try to get them in order. And remember, mnemonic devices like this for the wrist, they're always gonna go from thumb to pinky, always proximal to distal. So proximal being the first row, distal being the second row, always go from the thumb side to the pinky side. And that's true whether the hand is going like this or it's going like this, right? So no matter which way the hand goes, you can always go scaphoid, lunate, triquetrum, pisiform, trapezium, trapezoid, capitate, hamate. Got all that? Okay, so just to review some of these bones that we've been talking about, what bone articulates with the medial end of the clavicle? So think about the clavicle itself and then think about the medial end of it. What bone articulates with the lateral end of the clavicle? And then which bones articulate with the scapula? All right, so think about those for a second. All right, and here's your answer. So the clavicle itself, what bone articulates with the medial end of it, so towards the midline, is the sternum. So medial end of the clavicle articulates with the sternum. The lateral end of the clavicles go way out here, and they're going to articulate or join with the scapula. So that's all part of the scapula. And then if we're looking at the scapula itself, what bones articulate with the scapula? Oh, that's a typo in my PowerPoint. The ones that are articulate with the scapula are the clavicle and the humerus. Clavicle and humerus articulate with the scapula. All right, hopefully it's starting to sink in a little bit. All right, question number 2, describe the positional relation between the radius and the ulna. So the positional relation using some of this anatomical terminology that we've been working on, which one of these two statements is true? Is the radius lateral and the ulna is medial, or is the radius medial and the ulna is lateral? Think about it. Yep, so the radius is going to be lateral. Radius is always lateral. It's on the thumb side of the body. So if you're standing in anatomical position, the thumb side of your forearm will be lateral, and that's where we'll find the radius. Okay, so now let's get into the pelvic girdle. So moving down to the lower extremity. So we talked about all the bones in the upper extremity. Now it's time to move down. All right, so what you're looking at here in this slide is one of your 2 os coxa. So os coxa are hip bones, right? So you've got 2 hip bones. They're going to join together. Each one of these 2 hip bones actually articulates with the sacrum. And so remember, the sacrum is that triangular bone that's at the base of your spine. So each one of these os coxae articulates with the sacrum, and all 3 of those bones together them form your pelvis, right? So pelvis is made of 2 os coxae and a sacrum. So each one of these os coxae or coxal bones is going to be composed of actually 3 smaller bones. And they've been just sort of fused together, but they still have independent names. So looking at this, this image here, the large wing part of this bone on the top of the bone is called the ilium. Right, so the large wing, kind of elephant ear shaped portion of the bone is called the ilium. Down here, this kind of robust angled part of the bone down here, this is your ischium. So ischium, think of that as being your sitting bones. So when you sit down, and if you kind of feel a little, just go ahead and try to feel a little bony process on your bottom where you're sitting down, that's your ischial tuberosity. So ischial tuberosity would be this part of the ischium down here that you actually sit on. All right, and then this one up here, this kind of smaller, a little bit more delicate one is the pubis. So pubis is always anterior. So pubis is anterior, ischium is posterior, and ilium is superior. You can actually feel your ilium is going to be superior and anterior. When you can feel your hip bones, the ones that you're feeling are the ilia. Okay, so here's the whole pelvis all articulated together. So we can see over here, we've got 1 os coxa on this side, we've got 1 os coxa on this side, and then they're both attached to the sacrum, which is in the middle here. So each os coxa articulates with the sacrum. Where they articulate together is called the sacroiliac joint. So sacrum and ilium come together at the sacroiliac joint. Now, the 2 coxal bones actually articulate with each other anteriorly, and where they articulate together, the 2 pubic bones come together, is called the pubic symphysis. So pubic symphysis is where the 2 pubic bones of the os coxa articulate together anteriorly. All right, and that's that little pad of fibrocartilage I think we talked about last time. So that's actually a movable joint. It's not super highly movable, but there is some movement between those 2 hip bones at that pubic symphysis. All right, so let's look at each one of the bones of the os coxa so that we can understand some of the features of the bone here. So looking at the ilium is that kind of large winged superior anterior portion of the bone. It's those iliac crests you can kind of palpate on yourself. You can kind of feel those in your hip region. Other parts of the bone that we should pay attention to here are the acetabulum. So I'm going to circle that. Acetabulum on either side here. So the acetabulum is basically a socket, right? So it's like a hollow opening in the bone that the femur can attach to. So this is where your hip joint is within that acetabulum of the os coxa. Let me grab one so you can see. Here I am. Okay, so here's an os coxa. If I look at this os coxa, I can see that we've got the ilium up here, so this winged part of the bone is the ilium. Down here, this kind of robust part of the bone is the ischium, so that's where you sit, and this part up here is the pubis. Right, so pubis, ischium, ilium up top. So this would be the left os coxa, so on the left side of this person's body. I'm going to go ahead and articulate a femur in here. Let me back up so you can see it. So femur articulates right in that socket there. So socket is the acetabulum, head of the femur articulates in there, and that's how we have a movable hip joint. All right, so that's the acetabulum of the os coxa. We also have another structure here called the greater sciatic notch. So I'm going to go ahead and circle that with the highlighter. So greater sciatic notch, again, we have on both sides. So this is just kind of like an indentation in the bone. This is for passage of the sciatic nerve. So the sciatic nerve, which is the largest nerve in your body, goes down to innervate the leg. A large nerve has to pass through this bone, so it folds itself underneath that greater sciatic notch. Okay. All right, let's look at the other two bones here. So the ischium and the pubis. So again, ischium is going to be this sort of more posterior part of the bone. These are your sit down bones, the bones that you sit on. The ischium has these ischial tuberosities, so that's just the kind of lowest, most inferior portion of the bone here, the ischial tuberosities. Those are the ones that you can feel when you sit down. The pubis, again, this is the more anterior part of the bones. The two pubic bones here come together at the pubic symphysis, and that's what's holding your pelvis together anteriorly. Posteriorly, I just want to point out, the os coxa do not articulate with each other posteriorly. They articulate with the sacrum, and that's at that sacroiliac joint. Okay. All right, so this whole pelvis put together is really important for kind of obviously attachment of the legs, but also as sort of a basin for a lot of your abdominal pelvic organs kind of lie in this basin. So we make a distinction between what we consider the false pelvis and the true pelvis. So if we try to draw a circle here around the pelvis, around what we call this pelvic brim. So that pelvic brim is this circle that's created by all the bones of the pelvis fitting together. Anything above that pelvic brim is considered to be false pelvis. Anything that sits below that pelvic brim is considered to be true pelvis. So false pelvis isn't really going to contain many of your pelvic organs. True pelvic organs are going to lie within the true pelvis. All right, so here's a view of it from the side. So it's a little bit easier, I think, to visualize looking at it from the side. So we can see the plane of that pelvic brim. So if we're drawing that circle around the pelvic brim, it would be right here where I'm drawing a really messy line. Everything below that, so everything down here is considered true pelvis. And so stuff that we would find down there, you're going to find your reproductive organs down there. So you'll find uterus and ovaries and bladder in that region. Pretty much everything else is going to be false pelvis or above. Okay, let's look a little bit at differences between the sexes in terms of the bone structure. So we mentioned last time that males and females, because of hormonal involvement in the development of the skeletal system, can have some differences in the overall size of the bones, overall thickness of the bones. A lot of those changes become really evident when we look at the pelvis, and that's because pelvises are going to have some very different jobs depending on the sex of the owner of that pelvis. So for men, the pelvis is basically just a girdle to attach the legs to the rest of the body. All right, so the pelvis has this shape where we're looking at a male pelvis in this picture here, where the ilia are kind of winged up, so we can see how high these ilia are. And overall, the width of the pelvis is pretty narrow, right? So narrow and tall if we're looking at the overall shape of the pelvis. One other thing to note here is this pubic arch or the pubic angle. So the angle between the two pubic bones is very narrow, right? It's an acute angle, which is going to be different between males and females. Right, so if I switch over to the female pelvis here, so some major differences. One, instead of these ilia being high, they tend to go wide. Right, so we're looking at a wider pelvis, not so narrow, much wider, and not as tall. Right, so wider, narrower pelvis, and we've got a much wider pubic angle here. So the arch between the two pubic bones is much wider. It's going to be no longer an acute angle, so it's usually going to be greater than 90 degrees in women. And most of these differences between males and female skeletons has to do with childbirth, right? So just because the pelvis has to be able to fit a fetus through it, then becoming an infant through that pelvic canal, we have to make room, right? And so that's why the female pelvis tends to be a little bit wider and has more room for passage of an infant. Okay, so moving down into the leg here, we're going to talk about the thigh. So the thigh has one bone to it, and that one bone is the femur. All right, so the femur is the longest bone in your body. It's the heaviest bone in your body. It's the strongest bone in your body. And if you want to think about why, it's because that's supporting most of your weight. So whenever you're walking around, all of the weight that's being borne by the created by everything up here, so your head, your abdomen, all of that weight is going to be channeled down into your femurs or into your thighs, right? So let's look at the femur itself and note some features of it. There we go. So looking at the head of the femur, so I'm going to grab my femur here too. Right, so here's a left femur. If we look at the head of this femur, we can see that it's rounded. So this rounded head of the femur is important because this is where we create that ball and socket joint that we talked about with the acetabulum. So the head of this femur fits into the acetabulum of the os coxa, and that's how we form your hip joint. So within that head is this little indentation here, and that's called the fovea capitis. So fovea capitis is for attachment of a ligament that's going to help hold that hip joint in place. Also over here to the side, on the lateral side of the femur, we've got greater and lesser trochanters. So greater trochanter, lesser trochanter. These guys are large projections of bone. Those are for attachment of really big muscles. So a lot of the muscles that actually hold your leg to your body have to reach around and grab onto these projections of bones. That's what the greater and lesser trochanters are. Okay, so moving down, so if I look at this femur, and I'm going to raise it up here so you can see as we go down to the bottom or the distal end of the femur. So down at the distal end of the femur, this is where the knee joint is going to form, right? So the actual patella or your kneecap is going to sit right on top of here, and then the part of the bone of the leg is going to come down below this. So the patella would be sitting right here. Patella is one of those sesamoid bones that we mentioned. So sesamoid bone is one of those tiny little seed-shaped bones that tends to form inside joints to help protect the joint. So the patella is the only named sesamoid bone. It's kind of sits within the tendon that attaches your quadriceps muscles to the leg or to the tibia, which is the next one we'll talk about. All right, so moving on down into the leg. So your femur is in your thigh. Your leg consists of two bones, and those two bones are the tibia and the fibula. So tibia is the larger of these two bones. He's thicker, he's more robust. He's the one that actually bears weight. The fibula is a smaller, more slender bone that is always lateral to the tibia, is there for leg rotation, but does not bear weight. All right, so very different between those two bones. So tibia is the larger one. Tibia is medial, and tibia is the weight-bearing bone of the leg. Fibula is lateral, does not bear weight, is there to create rotational movements of the leg. All right, so there we can see the fibula. Now both of those bones, the tibia and fibula, are going to articulate with a major bone of the ankle called the talus. All right, so here let's look at the foot and the ankle joint here a little bit. So let me grab a foot. Here's a foot. So here are all the bones of the foot. So we're going to talk about these kind of the same way that we talked about the bones of the hand. But first let's kind of consider that ankle joint. So if I'm looking at the foot from the top here, this bone right here, the top bone of the foot, is called the talus. The talus is going to articulate with both the tibia and the fibula, and that's what creates your ankle joint. So a lot of times the ankle joint is called an ankle mortise, and this is a woodworking term to do with the type of joint that you can create between two pieces of wood, but it fits for this. Basically what happens is your tibia and fibula, which are right here, tibia, fibula. If we put these two guys together and we kind of zoom in on the bottom where these two bones come together, they create this sort of rounded surface, kind of like an arch here. And the arch of that rounded surface is going to be where your foot actually fits in. So the talus of the foot is going to fit in between the tibia and fibula there, right? And that's what creates your ankle mortise. It's holding the ankle joint together, right? Okay, so the bones of the foot, again, similar in kind of the breakdown to how we talked about the bones of the hand. So your foot is going to be composed of tarsals, which are the bones of kind of the ankle, and then the metatarsals, which are the bones of the sole of the foot, and then phalanges, which are the bones of the toes. All right, so we'll start off by talking about the tarsal bones up here. So we mentioned the talus already. So the talus is the one that's going to articulate with the tibia and the fibula. If we look to the heel, so your heel bone, that really large, robust bone that's on the heel of your foot, that one's called the calcaneus. So the calcaneus is the largest bone here. It sits right underneath the talus. So talus is the one that articulates with the bones of the ankle. The calcaneus is your heel. All right. I'm going to rotate them around so we can see the top of the foot here. So again, calcaneus, talus. If I look at the bone right in front of the talus here, this guy's called the navicular. So the navicular is always on the medial aspect of the foot. Over here on the lateral aspect of the foot, this bone is called the cuboid. So navicular, cuboid, and then we've got three little bones here. Those three little bones are cuneiforms. So they're called your first, second, and third cuneiform, and they're just kind of numbered in order. So those are the bones, the 7 bones of your foot. So calcaneus, talus, navicular, cuboid, and then first, second, and third cuneiforms. Right, so those are the ankle bones. Then we move down into the bones of the foot itself. So these are your metatarsals. Metatarsals are just numbered the same way the carpals were numbered, or the metacarpals were numbered in the hand. So first metatarsal, second metatarsal, third, fourth, and fifth. So the first one is aligned with the big toe. The fifth one is aligned with the pinky toe. Okay, so that's a better view of it in that picture there. So we can see all of those ankle bones that I was just mentioning, in addition to the metatarsals, which again are just numbered 1 through 5, and then the phalanges, which are the bones of the toes, and these have the same exact format as the bones of the hand. So we've got, for your great toe, you've got the proximal phalanx and distal phalanx. But for all other toes, it's proximal, middle, and distal phalanx. So there's 3 phalanges for each of your toes, except for the big toe, which only has 2, just like your thumb only has 2. All right, so the way that these bones are arranged in the foot is in a really specific way to create arched support, right? So feet have to carry a lot of weight. So we're always walking around on our feet. We only have 2 of them in contrast to a lot of other animals who are able to distribute their weight onto 4 feet. We've only got 2. And all our weight is directly down onto those 2 feet, which means that we had to create these arches in order to support the weight of the body. So we've got longitudinal arches. So longitudinal arches are ones that go along the long axis of the foot, so longitudinal this way. And then we've got a transverse arch, and the transverse arch goes the other way. Basically, the combination of that lateral arch and that transverse arch, arches are really strong structures that they're going to help hold the weight of your feet. So if those arches fall, right? So if you're not able to maintain that arched foot, then you get what is known as flat feet, which makes walking very painful because you don't have the arched support to carry the weight of your body. Okay, so a couple questions here. What is the only weight-bearing bone of the leg? Kind of a trick question, maybe not totally a trick question. So think about the bones of your leg, and then which one of them is the only one that bears weight? All right, and then the second question here, tibia and the fibula articulate with which bone of the ankle? So which one of your ankle bones, which one of your tarsals articulates with the tibia and fibula? Okay, so the answer here for the first one, the only weight-bearing bone of the leg is the tibia. If you said femur, you're not totally wrong. The femur is a weight-bearing bone, but it's not technically in the leg, it's in the thigh, right? And the thigh is a different structure than the leg. So tibia is the only weight-bearing bone of the leg. And for the second question, the tibia and fibula articulate with which bone of the ankle? The answer there is the talus. So the talus is the bone of the ankle that articulates with those two bones of the leg. Okay, match these bones with their location. So carpals, metacarpals, metatarsals, and tarsals. So think about where those bones are in your body and let's see if we can match them up. I'll give you a second. All right, hopefully that's enough time. All right, so your carpals are the bones of your wrist. Your metacarpals are the bones of your hand. The metatarsals are the bones of the sole of the foot. And the tarsals are the bones of the ankle. All right, so I hope this has been helpful. We've kind of gone through all of the appendicular skeleton at this point. So put all 126 of these bones that we just talked about together with the 80 that we talked about when we considered the axial skeleton, and there you have all 206 bones of the human body. Practice these, review this PowerPoint, and try to see if you can learn all of these bones. All right, let me know if you have any questions.